So for chapter 25, we're going to do two problems. We're going to do number 10 first. So problem number 10. In this problem, we've got a scuba diver that's training in a pool and looks at his instructor's face as shown in the figure. What angle does the ray from the instructor's face make with the perpendicular to the water at the point where the ray enters? And then the angle between the ray and the water and the perpendicular is 25 degrees. So this is the picture that we have basically drawn in the book. We have this interface. So up here we have air, and down here we have water. And we're looking down into the water. What happens when light hits water? Does it keep going straight? No, what happens to it? It diverges, it moves. What do we call that divergence? Refraction. And refraction is always measured relative to a normal to your surface. What does normal to a surface mean? What's normal? Perpendicular. So we have a 90-degree angle. Okay. So any angle that you're measuring is always relative to a 90-degree angle from your surface. So I have this light ray that's coming in and the light ray that's entering the water. If I'm given angles then, I'm given an angle, let me get the exact phrasing. The exact phrasing is the angle between the ray in the water and the perpendicular to the water is 25 degrees. So that's usually the hard part of these problems, figuring out what angle they're actually giving you. The angle between the ray and the water. So which one would that be? This one up here in the air or the one in the water? The one in the water. It's the ray in the water. And the angle between that and a perpendicular to the water. So the perpendicular to the water, would that be this angle that's next to the red line or this angle that's next to the horizontal line? Which one of these lines is perpendicular to the water? The red line. You're always refracting relative to that perpendicular line. So that 25 degrees is this angle right here. So we have something light refracting here. What equation is relevant for refraction of light? Snell's law, the law of refraction. And what is that? Sine theta 1 equals n2 sine theta 2. Okay. What are our two ends? What are our two interfaces? Air and water. So we have n in air times sine of the angle in air. If I were to draw that in this picture, where is the sine? Where is that theta 1 going? Theta in the air. It has to be in the air, right? I have a choice of two different angles. I can pick this one that's relative to the horizontal, or this one that's relative to the normal. Which one? Always relative to the normal. So this is going to be my theta in the air. This is what I'm looking for. And that equals n2, which is n in the water, times sine of theta 2. Can I plug in some numbers? Do I know what the index of refraction is in air? Yeah, what is it? 1. So this just goes to 1 times sine of theta air equals n water. Do I know the index of refraction of water? What is that? Is 1.33 times sine theta 2. Do I know theta 2? What is that? 25. So I can plug in some numbers. 1 times sine theta air, I just still have that sine of theta.
1 point equals 1.33 times sine of 25. If you plug that into your calculator, you should get 0.42. I'd plug it in, make sure you get 0.42. If you don't get that, you're probably not in degrees. So make sure you're in degrees. And once I get this number, how do I find theta? How do I get rid of the sine? Theta air is the inverse sine. Sine to the -1 of 0.42. And you should have that button on your calculator. So theta air, once it's all said and done and plugged in, oh, sorry, I skipped one step. So we get the sine of 25 is 0.42. Did we get that? No. On your calculator?
I got 0.56.
Yeah.
For sine of 25?
Yeah.
Ah, so that's what I skipped. So 1.33 times 0.56. What do we get? 0.56? Okay. So then here we have the sine theta is 0.56. And we take the inverse sine of 0.56. And we should get 34 degrees. Okay. Any questions on number 10? So the other problem we want to do is going to be 42.
Would you give us the constants of
The indices of refraction? I'll give you those. Air and water, I'll let you know what those are. So let's look at number 42. So number 42, we have a doctor, and this doctor is going to examine a mole with a 15 centimeter focal length magnifying glass held 13.5 centimeters from the mole. Part A, where is the image? Part B, what is its magnification? And part C, how big is the image of a 5 millimeter diameter mole? So how big does this mole actually look? What variables did they give us there? Doctor examines a mole with a 15 centimeter focal length magnifying glass. So what letter represents the focal length? F. So F equals 15 centimeters. That magnifying glass is held 13.5 centimeters from the mole. So what does that 13.5 centimeters represent? Distance of the object is 13.5. Part A, where is the image? So what am I looking for? What variable? DI. What equation can I use? 1 over focal length equals 1 over DI plus 1 over DO. What is that equation called? The thin lens equation. The thin mint equation. So I can plug in my variables. I can plug in 1 over 15 for my focal length equals 1 over DI plus 1 over 13.5. I do my algebra, I've got to get DI by itself, so I subtract the 1 over 13.5 from both sides. So I have 1 over 15 minus 1 over 13.5 equals 1 over DI. I do that subtraction. Do that for me. Let me know what you got in your calculators. I did this last night, so I can't read my own handwriting. There we go. Negative 0.0074. Do we have a negative distance of the image? Is that possible? Yeah, sure. Not a problem. Now, is that the distance of the image? No. What do I have to do? I have to take 1 over that. I have to take the inverse. So my distance of my image when I take that inverse is negative 135. What are the units? Centimeters. If you look in the solutions manual, they'll give you the answer is 1.35. Why did they get 1.35? They gave it in meters. You don't need to. As long as all of your units, as long as they're all measuring the same thing, these are all measuring distances, you can leave it all in centimeters. That's fine. It doesn't matter. I don't care. Part B. How do I find the magnification? What's the equation for magnification? Right there on the board, negative di over do. Negative di do. Anybody remember that singer?
Yeah, of course.
Dido? Yeah. Now I want M&Ms. I'm very susceptible to advertising. Negative 135 over 13.5. Now, without using your calculator, can we take 135 and divide it by 13.5? What do we get? 10. What are the units on that? I'm going to make this worth some Jeopardy points. I'm going to give 500 points. If you can get the units of magnification. I don't want you to tell the answer. I want you to.
Can you say the ones you want?
Huh?
Units of magnification.
What are the units of the magnification?
Points.
500 points. Write your answer down there. What are the units of magnification? Write it down, write it down. What are the units of magnification? I'm going to come around, I'm just going to look at it.
That doesn't make sense. Diameter is a unit. Right? Units as in like meter squared or something. Diameter is just, it's a circle, that's diameter.
What do we got? You got it?
Nah, I will do.
You give up?
That thing is just wrong.
You sure?
Yeah.
No answer?
No. Just say it. You might be right. No.
Just say it.
I am doing say it.
Might as well guess.
Say what you put. Say the diameter. You said the unit of the thing is the diameter.
Okay.
Minus 500. Professor. Everybody's about to get excited about this one. It's unitless. Right?
Unitless. No units.
Right, I'm taking a distance and divided by a distance. Centimeters divided by centimeters, the centimeters cancel out. No units for magnification.
Okay. Then the last question, last part of this. Was asking, how big is the image of a 5 millimeter diameter mole?
So how big does this mole look through this magnifying glass? How would I figure it out?
DI over DL?
I already did that.
Oh.
Magnification is 10. So anything that I look at through this magnifying glass is going to look 10 times bigger. So how big does this mole look? 50 millimeters.
So it's magnified to 50 millimeters.
Your magnification, multiply it by whatever your height of your object is, that gives you the size of the the size of what you supply by magnification.
Okay.
Does this mold look big? Goes from 5 to 50 millimeters? Still kind of creepy though, right? Disgusting. Nope. No skin doctors in here, right? No. Creeps.
Okay, that's all we have.